Hey everyone, this is video 10, and in this video we are going to investigate multi-step conversions having to do with stoichiometry. Okay, so we already know how to convert grams into moles and moles into grams using the periodic table. And I like to write this little mole map. So moles are kind of like the jack of all trades. They can be pretty much converted into anything. So to go from moles to grams and vice versa, we use the periodic table. We can also go from moles to molecules by Avogadro's number. And we can go from molecules to atoms by the number of atoms that are in that particular molecule, just by counting out. So say like in carbon dioxide, you know that the formula is CO2. That means there's one carbon and two oxygens, so 3 atoms total. So you could use that in any kind of unit conversion. And being that you guys are already really good at physics, this should not come as too much of a surprise that you can do multi-step conversions. It's just now we're doing that in the context of chemistry. So they want to know how many molecules are in 2.56 grams of carbon dioxide. We're going to start with the number they give us, and then our goal is to get to molecules. So 2.56 grams of CO2. Okay, and we're going to do parentheses here. We're going to put grams of CO2 in the denominator, and we can look at our mole map here and see where we can go from grams. And the only place is moles. We can't go directly to molecules. We have to go through moles first. So we're going to go up here to mole CO2. How many grams are in 1 mole of carbon dioxide? For that, you have to calculate the molar mass. So I'm going to do that over here. The formula is CO2, so it's going to be 12.011 for carbon, plus 2 times 15.999. And just going to quick do that on my calculator. So 2 times 15.999 plus. Okay, so that's 44.009. I don't know if you need that many sig figs, but what the heck. Okay, and that's going to go in front of grams. So 44.009 grams of carbon dioxide in 1 mole. If it's a different substance, then you're going to calculate a different molar mass for that. Okay, and then we're going to take it another step now. We're not done. So now moles of carbon dioxide is up here. We're going to put moles of CO2 on the bottom. And now we can go to molecules. So molecules, there are 6.02 times 10 to the 23rd molecules in 1 mole of carbon dioxide, because that's Avogadro's number. And then I can just calculate this all out in one fell swoop like we did in physics. So you're going to multiply by every numerator and divide by every denominator. So this is going to end up being 2.56 times 6.02 E23. Remember your scientific notation on the calculator, divided by 44.009 equals. And that's going to be 3.5. Actually, we need 3 sig figs. So 3.50 times 10 to the 22nd power molecules. And you're done. So multi-step.